Okay, so continue. For example, here the example 15 show that you can express sine x minus root 3 cos x in the form of r sine x minus alpha, where r is greater than 0 and alpha is from 0 until pi over 2. The way is just the same like before, right? We're going to have two equations right here. R sine alpha over r cosine alpha. Here is gonna be 1 root 3 over 1. That's why here tangent root 3. And then the alpha you will get from arctan of root 3, right? That's why here pi over 3. And then squaring and adding r, you will come up with the value of 2. Where does it come from? From here, yeah? R squared is equal to the coefficient, the first coefficient, which is 1 squared plus root 3 squared. So that's why R here root 1 plus 3. This is 2, yeah? It's supposed to be plus minus 2, but the problem here is R, remember, the terms R need to be positive. That's why the one and only r that we have is only 2. So no need for minus. Okay. After that, we will come up with this r and here also the alpha. Then we have done for part A, right? For the part B right here, hence sketch the graph of y sine x minus root 3 cos. The problem with this function is it's hard for us to sketch the graph of this function. Why? Because it has two terms of trigonometry function that are different, which is here sine, here cos, right? That's why it's hard for us to sketch. That's why we need this form so that it will be easy for us to use it. Okay, something like that. So that's why if we have already the part A, which is 2 sine x minus pi over 3, that's why we can sketch the graph. If you still remember what is the original sine graph, this is 1, right? This is minus 1. So that's why it's supposed to be like this. And then here it's supposed to be like this, right? But then why means it becomes 2, it becomes the graph, it becomes 2 right here? Because here, remember, we stretch the graph. That's why we stretch the graph. And then here, this is inside of the brackets changes, right? Remember, if it's negative, actually it will move to, yes, correct, to the right. How many units? Pi over 3 units. Then done. That's why here the fx for 2 sine x minus pi over 3. Okay, I think that's clear enough, yeah? Okay, let's just do it like the same way as before, yeah? So this is gonna be 2 cos theta plus 5 sin theta will be equal with r cosine sine okay. After that, here 2 cosine theta plus 5 sin theta, here r cosine theta cosine alpha plus r sin theta sine alpha. So this one we will come up with the value r cosine alpha equal to 2. Still remember, this is the same, this is also the same. That's why we will come up with these two equations right here. R sine alpha equal 5. Okay, so Later on, you will find out r sine r cos alpha. Here will be cos sine is 2, 5 over 2. So this gonna be cancelled. This gonna be tangent alpha. 5 over 2. If you use your calculator, you will come up with the value of alpha 68.2 degrees, right? After that, here for another one, we're going to find the r. So r squared is equal to the, still remember, cos squared alpha plus sine squared alpha. Let me just directly use this, yeah. So that's why here we will come up with the value 2 squared plus 5 squared. Here r squared equal 4 plus 25, 29. So r is equal root 29. So yes, this r, let me just change it directly, becoming root 29, and also this alpha, no longer alpha, but it's become 68.2 degrees. Then done, right? Okay, now we're going to go to solve this equation. The question in your book here is solve for 0 degrees till 360 degrees. Okay, from this equation, for 2 cos theta plus 5 sin theta. Okay, so we have found already that this 2 cosine theta plus 5 sin theta before is actually equal to the root 29 cos theta minus 68.2 theta right here, right? Okay, so how do we solve this then? Okay, better let's just use this form. Why I said like that? Because it's hard for us to find the theta if it's like this. So we are going to use this form. How we are going to use this form? Then pay attention. This is 29 cosine theta minus 68.2 degrees. This is equal to 3. Okay, then let's just make it equal to 3. This one is, I think, already clear, yeah? Okay, so next. Okay, so we will have cosine theta minus 68.2 degrees or equal 3 over root 29. Okay, like that. Now, after that, I told you before, we have learned this before, right? In the pure math 2. How we are going to solve it? Remember, if we are going to change it, to solve it, we just use or let this one becomes one angle only. Then let this write, let theta minus 68.2 degrees becoming beta. So we will have cos beta equal with 3 over root 29. If we are going to find the beta, so we will come up with the value of r cos of 3 over root 29. If you use your calculator, you will come up with the value of 56.1 degrees. Okay, for beta. But now, is that beta that we are going to find? It is not. What should we find then? The theta. That's why we need to change again the beta, go back to the original form. Okay, so we change it back again into theta minus 68.2 degrees. Okay, this one will equal to 59.1 degrees. But the problem, is this the one and only value that we need to check? Okay, let's check here. How we are going to check then? Okay, remember this beta is actually having another interval. For eta, earlier we have it is work from 0 until 360, right? Okay, like that, right? But because since we have beta already, it's no longer beta only. Then it's going to be 0 minus, what is it? Correct, 0 minus here 68.2 degrees. Why? Because the theta will be changed into the original eta. The 360 also we need to subtract with 68.2 degrees. Then here will be minus 68.2 degrees. Here eta minus 68.2 degrees, which is beta. Here will be 91.8 degrees. Remember this is beta. Okay, so after that we know already beta, the interval of beta. Now we can check how many quadrants that we are using, that we are going to check if we use this interval. Correct, we will use 4 quadrants positive and 1 quadrant negative. Okay, for positive quadrant, here 90, here 0 or 360, here 180 degrees, here 270 degrees. Okay, we are going to check 4 of them, but then let's check only the quadrants that make the value of cosine positive. Where is the cosine positive? In quadrant, this is all, this is sine, this is tangent only, this is cosine. Okay, so only at this quadrant 1 and also 4. Okay, in quadrant 1 we have it already here. Now let's check in quadrant 4. In quadrant 4, it's supposed to be 360 degrees minus 56.1 degrees, right? So we will come up with the value 3.9 degrees. Okay, like this. Right. Is this included in the interval? No, right? Because the interval is only until 291. So this one is not included, then we can just throw it away. We will use this one. Okay, that's for positive. Now we will check in negative intervals. Okay, so still remember in first quadrant, this is first quadrant of positive, yeah? In first quadrant of positive is actually, in first quadrant of negative is actually the fourth quadrant in negative. So we will just check, just use it. Okay, so because this one is alpha, the alpha is already 56.1 degrees, then actually we can use this, just the inverse. What is the inverse of 56.1 degrees in negative quadrant? Yes, correct, it's going to be negative 66.1 degrees. Okay, then done. Okay, so we will have 2 values of degrees that we need to check. Okay, next, after we come up with that 2, we can find 2 values of theta also. Negative 56.1 degrees. Here theta becomes 56.1 degrees plus 68.2 degrees. Theta becomes 0.3864 12. Or we have another eta right here, minus 6.1 degrees, positive 68.1 degrees, sorry, 0.2 degrees. So this one becomes theta equal to 1.21 degrees. Then done. Okay, so that is the way to solve the trigonometry equation. Thank you.